Okay, if you saw either the source code or the article or the summary or maybe a tweet about this, this application I just wrote is on using multiple vectors together in the same collection, which is the cool features of Milvus. Could actually have up to 10, and that'll increase in the future. But I have one that's for an image and one that's for text. Pretty cool. So first thing we have to do is get the data we're going to use. We're going to enrich it because we get lat and long. With latitude and longitude, I have location. With location, I can get other enrichment data. For this first pass, I'm just grabbing weather for that regionalized area. And we'll format stuff, get it ready, and then we're going to store it in Milvus. We're going to do an insert. We're going to create a bunch of scalars. This is all the metadata fields, like the roadway name, humidity, that sort of fun stuff that we get from one of the two rest points. And then we're going to add the two vector fields. One for the text, that's going to be the description of the weather forecast, and one's going to be a camera image. Then we're going to do this in Python script I call streetcams.py. Then we're going to use some open source models. You don't have to pay for anyone's different services there to do data queries on this hybrid multimodal multi-vector search. And we'll show you how you can query data, re-rank it, get this displayed in a notebook, and we're just using a standard Jupyter notebook, and we'll display those text and images. And finally, I'll show you a Python retrieval augmented generation RAG application that uses LangChain in Python to take that data set that we loaded into Milvus collection and use that to enhance our ability to do LLM. And we'll be doing question and answer powered by Ollama locally. Again, no cost. Running a Llama 3 model, all in Python. And we'll output it to the command line, but we're also going to send it to Slack. And new feature I've added there is it's formatted nicely in Markdown. And so we're going to have a full application here, starting with a couple REST endpoints, grab traffic camera images, grabbing weather forecast, using the current observation thanks to NOAA, sending stuff to Slack, putting documents into Milvus. Pretty cool stuff. Like I said, we have a full article on that, so you can get into that. But let's look at the source code. Got a couple different ones. That one's for a future one. So first one, most important, a lot of imports here, surprising, is the streetcam. This is going to be the one on the command line, or, however you distribute, run it. This could be set to run different ways. Maybe we'll change this to Spark or something else. But for now, simple app running from command line Python. I'm going to grab a free model here in a sentence transformer. That's my embedding function, the all mini LML6 version 2, just using CPU. I'm running on my Mac here. And this is a nice one that comes with Milvus models. Make sure you install that. And we got that linked elsewhere. In my environment variables, I've got one for the URL for the street cams. You have to sign up for this to get permission, so we can't display that. Set our name for our collection, do whatever you want. And we're going to have Milvus. This could be a local Milvus-like database. Could be local cluster, could be in Docker, Docker Compose. Mine's in Docker Compose, running amazingly on an NVIDIA Jetson Orin that we used in some other demos, and we're going to be using that all the time. It's a pretty awesome machine. But again, that could also be used in Zilla's Cloud. If you haven't tried Zilla's Cloud, it is pretty cool, and I highly recommend it. It is very easy, and you don't have to do any of the work. Also has some significant performance enhancements, and really easy to use. But just to give you a quick look out here, nice format display here. Lots of ways you can learn how to use the different APIs, see how you could do different kinds of searches and stuff, do upsert, and view what data we have in here. Some of it uses for a vector search, and it preloads it really nice. Get the top 100. We could filter with different conditions, pick which output fields you want. It's a nice tool to have just to give you the flexibility there, depending on what you want to do. The only difference you got to do is add the Zillus token, which again, put that somewhere secure. Don't just leave that in your source code or notebook. Maybe when you're developing, that's okay, but go on. There is a lot of this one is pretty standard. This feature extractor we use on our images. This uses my favorite named library, Tim, which is a great library. This one's we've had this in a bunch of our demos. You could find this in our public boot camps and stuff. And this one works really well. There's some links to help you there. And we're going to use ResNet 34. We probably should update to ResNet 50 or a different model, but the images are pretty small and low resolution coming from street cameras, but we can think about it. Now I've got a little function here, takes the lat long and some fields and formats the text that we want to be that description of the weather. And I figured to put that in a function. And I've got one that parses out the weather. The weather comes back from NOAA, REST feed, and some giant JSON. Here we call it, we get as JSON, we pull out the fields we want. And sometimes they're empty, which foreshadowing, when I ran this enough times, you get some janky data back once in a while, but we fixed it. Now there's an awesome model out there. Again, there's a lot of other options, but I've been playing around with Ultralytics YOLO version 8 a while. Works pretty quickly, works pretty well. Maybe we'll try another one at some point, but I like this. These guys are cool. We connect to Milvus, again, using that URL. Could have a token, could not. And this is the big part here is we're going to create our collection if it hasn't been done already. Obviously, you saw it was created already, but first time you run it, so you got to create it. We use a primary key, let Milvus handle that, make that auto done. Then we put our scalar fields here, latitude, longitude. Again, those could be floats, but keep them string. Roadway name. So we've got a ton of them here. And like temperature is a float. You get a lot of different types here. You can also put arrays. And we got an article on that. Could do them as JSON. So it could be dynamic. If things are changing. Again, that's probably not the best for trying to search. But, if you know what your schema is, define it. Best performance always. And you could then decide to put on indexes and whatever. And you see here at the bottom, well, this details, big string here, is because that's that chunk of weather forecast we built. And then there's the vector for the image. 512 is the dimension. Could be a lot bigger. Depends on how many dimensions you want to do and what encoding, lots of stuff there. And there's the one for the weather text, just 384. So we create our schema from all those fields. If it wasn't created yet, we created it. If so, it just says it exists, and you'll see that when we run it because it does exist. So we create the collection. We add a couple indexes, one for image, one for the ID, one for the other vector. And then we just connect that to our collection, check the status, print that out for you. Now, you could add a lot more indexes, different types of indexes. This is where Milvus is insanely flexible. But, your mileage may vary. What you need to do there is you could pick that. So we're going to grab that list of cameras, format as JSON, initialize a couple variables, and now we're going to iterate through that list, which right now is like 1,500. And if it's not disabled or blocked, good fields to have out there. Though once in a while the camera's down and it's not listed here. Sometimes stuff gets on the camera, or they have internet difficulties, I guess. So we go here, we will grab all the fields there, setting defaults, because Milvus got to have data no nulls yet. We don't have that support. Probably don't want that, but we'll see. So we build up our weather URL for that lat and long. We're going to call that and parse it. set those fields, anything that could be null, put a default. We set our image here, format those weather back. Here we're going to make sure we save that image that we got from the camera. Going to pass that through YOLO with hopefully as much debug info off as possible. We get our results back, bunch of stuff here. Going to write out that new enhanced image, save it, and we're going to keep all the verbose results here, format that up. If we want to put that in there, maybe we're going to do an enhancement on the fly. This will show up in our Slack thing. Make sure we save that. I like that. Good feature. Okay, next is most important insert. Gonna run that on the image, get the vector on the text using that sentence guy we had set up before. Make sure things aren't null, set some defaults. Do our insert on that collection, pass in the 2 vectors, all those fields. A lot of fields, and that's it. We run it. And I have that running down here. Probably should restart that run as I put in some new fields. But up to you there. You know, what you're going to do. Do we use that text here? See, I turned off Slack because I was doing Slack on every insert. That's a lot of inserts. Should see if we actually use that text. Or we don't use that till later. No, we don't use that. Oh well. Okay, so we got it inserted. Really important. Next thing we want to do is actually look at it. Now, we could see that as it's coming in. And we know that's coming in. Let me go over here, reload this. 19,000. As you can see, getting more data here. We can see all those fields we set up in the schema. There's a lot. The 2 vectors, our float guy, our really big string, our ID, and you can see the indexes here. And we could do a search on here. What's cool is search on both of those and mess around with the parameters depending on what query you want. Pick which re-ranker you want. And we could search. You could also start filtering that. You know, something like we could look at the area description. I found out we're getting data from Central Park, which is pretty cool. Ever been to Central Park in New York? Okay, so there's a bunch there. Another thing is I didn't set up a proper date field. That's my bad. I should do that. But for now, I could just search on today's date. August 29th. Again, it's a big string. I could have stored it as a date. But, I'm not really using date for much. But as you can see here, we have the area, and it's enhanced by what came back from the detection. You know, there's some buses. As you can see, there's a lot of data, a lot of different fields in here. There's those weather details. And we could just browse the data as well. And there's a lot there. Now we can also, you know, filter this out same way we filtered out the other one with any of the fields. It's a good way to do that. Something to look at, just so we know, yeah, data's coming in. It's still running. Ooh, we got an error. Oh, maybe because I just saved that thing. See if that change broke something. Sometimes you change something on the fly thinking you're smart, you break something. Okay, this is all in the article. And this is the notebook that you can get out of our GitHub over here. And I've got that linked in the article and some other places. So let's go run this. Let's make sure we have all these libraries. We're going to make sure we got that environment set up. Make sure we got the sentence embedding. Warning, we probably got to upgrade something. Make sure we got that feature guy ready. Oh, someone messed some up there. Okay, let's make sure he runs. He ran. Make sure we got collection. Again, we don't need to recreate it. I don't know why it's trying to recreate it. Let's not do that. Probably should have a flag in there like we did on the other thing. Okay, that worked. Let's take a look at our search. I'm going to pass in text string and an image as an example to be used for querying. This is nice, so you could just pick any image and use it to search on, but we're also going to be searching on the text. So let's run that guy. So that's text of weather and of a particular image. We set up our two search parameters as search requests here, combine them, and then do our search with those two requests. Re-ranking strategy. Output fields we want. I don't know why I wanted the ID, but okay. And then we'll display them, and we could display a bunch of fields here, but I just got the ones I think are major here. The weather details and the image. See here, I found one car. Really? These aren't cars? Yeah. I'll play around with different algorithms. And there's links to everything over there. Now the last piece is we're going to run the rag, which we're going to have to do in another window because that insert's still running there. So we're going to run the rag. Let's see if I created a shell script to make that easier. I did not because I'm lazy. Okay. So we have street cam rag. Hopefully you didn't break anything in the last 2 minutes when I've been trying to clean up the source code. I did. What did I do? I changed some code. Let's see. Did we change any code here? I didn't think I changed anything. Let's see here. It looks good. I don't think I changed it. Let's make sure. Maybe shouldn't have all this stuff running. Maybe we're at our resources. Oh, that's the server over there. You saw that demo before. Okay, let's give this a try. Missing required argument, recursive guard. What did I do? I don't know what I changed. I changed something very recently that was a bad idea, clearly. But we will get back to that. Okay, so I guess I fixed it. I didn't see anything. Sometimes just reloading the Python environment. And I got to clean up that warning. But if we look at previous runs here, we can see some good questions. Build a weather report. I could do that. For Central Park, and that's in New York. It's going to run that, and then it's going to give us the results, calling Olama over here, and getting the results, and then posting them here. And that shouldn't take too long. As you see, it's building it up. And when it's done printing it to the console, then we will post it into Slack channel, as you can see here. Pretty straightforward. That was it. Thank you.